Good afternoon, everybody. Welcome to the video on graphing skills, which is actually very important. When you're doing a graph, you have to do it properly because the graph is where you get your answer from. It could be the slope, it could be either the x or y intercepts, or you may use the graph to generate an equation that will lead you to your answer, but you have to do the graph correctly. So let's start with the first rule of graphing, is that your graph needs to take up the whole sheet of paper. Of course, you're going to need some room on the margins so you can write your information, but it should use the whole sheet of paper. So I'm going to come over to the left side for my y-axis, leave some room on the side there, and then draw my my x-axis, and of course leaving some room on the bottom. And for the most part, I consider this the whole sheet of paper. Over here we'll write whatever variable is our dependent variable that goes on the y-axis. So I'll name the variable, and today I don't have anything, so I'm just going to call it y. And then in parentheses I'll put whatever unit that was. Maybe it was a force, and the unit for the force is in newtons, so I would put that symbol in the parentheses. And then over here on the x-axis is where you put your independent variable. And again, I don't have anything today because we haven't done any labs yet. So I'm going to write x, and let's just say, for example, it's time, and time is in seconds, and so I would write an s. So there's my x and y axis. Your graph always needs to have a title, and the title of the graph is always the y-axis versus the x-axis. So y versus x, and of course whatever is on that y-axis would go there, and whatever variable is on the x-axis would go there. And so that's how you get the title of your graph. So I have my axes labeled, I have the title of my graph labeled, and now you would scale your graph. Now the best way to scale a graph is to have 4 increments or 5 increments per hash mark. And today I'm going to choose 5, I guess. 1, 2, 3, 4, and there's my first hash mark. 1, 2, 3, 4, here's my second. Because it's really easy to split time in quarters or 2/10, or it's really easy to split a mass in quarters or 2/10. When you start getting into these gray areas, let's say you have 3 hash marks or 3 lines per hash mark, it's really hard to split things in thirds. The math starts to get complicated. So do 4 or 5 per hash mark. 1, 2, 3, 4, and there's another one. 1, 2, 3, 4, here's, and so on. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now you're going to graph your data. And I know it's an assumption, and I'm going to make that assumption that you all know how to graph. You've all been through Algebra 1, you've been through, or you are currently in Algebra 2, and so you know how to graph your points. So I'm going to just go ahead and put some points on here from some imaginary data that I have. And when you're doing a graph, of course, the more points, the better. I like anywhere between 6 and 8. So when you're doing a lab and you have to collect data, I would do between 6 and 8 points in your lab exercise. That way you can get a pretty good graph. So after you place your points, now you want to do the line of best fit. And this is AP Physics 1, it's algebra based. And so we always like to have our graphs resemble a line, a straight line. If you graph your data and it doesn't resemble a straight line, I will show you in the future how we tackle that. That's called linearizing data, and that's going to be a future video. So right now I'm going to draw my line of best fit, and you need the line that comes closest to all the points. And if it happens to go through a point, that's okay. Sometimes the line will go through 0, sometimes it won't. The line falls where it falls. So let's see, I got I can actually see through my ruler, and I have this one, this one, this one below, and I have 1, 2, 3, 4, 5 above. So I'm going to tilt a little bit closer towards these upper points, because you need a line that comes closest to all of them. And then I'm going to draw my line, straight line. There you go. There is a nice looking graph. I'm missing a couple of things. One of the things I'm missing are error bars. Anytime you do a lab, the points you collect have error around them. Nobody's perfect. And so to signify that there's error, we're going to put these error bars. And so here are my error bars that I'm placing around all my points. And there we go. That's a decent looking graph. I have a title, my axes are labeled, I have my data points, they have their error bars around them, and I have a nice straight line. And then from this point, you can pretty much come up with the answer for your experiment. It could be the slope. If the answer is the slope of the line, and I know it's been a long summer, I'll give you the equation. The slope, m, is y1 minus y2 over x1 minus, oops, I got that backwards. So it's y2 minus y1 over x2 minus x1. And so where do we get these x and y points? Most students want to use data points. That is a huge, huge error. You do not use data points. You never use data points in finding the slope of a line. What you use are points on the line. And so I'm going to choose that point right there. It's at a nice intersection. And then at least half the line away, choose another point. And I have a point way up there. And so these are my 2 points that I'm going to use to find the slope. This would be my x2 and y2, and here would be my x1 and my y1. So whatever these numbers are, whatever x2 is, so I would follow it all the way down to the x-axis, I would get a number, and I'd place that number there. Then I'd go to my x1, I'd follow it all the way down, get a value, place that value there. I'd go to y2, follow it all the way over, get a value, place that number there, and then I'd go to y1, follow it all the way over, and get the value, place it there. That's how you get the slope of the line. And we'll do that plenty of times this year. Let me see if there's anything else I need to tell you about properly doing a graph. We will discuss again at a future time what to do if your line is not straight. Maybe it's curved, maybe it's a parabola, maybe it's a hyperbola, maybe it's inverse square. Whatever comes up, of course, I will show you how to handle that and what you do to turn it into a line, and then once you turn it into a line, what that means for the answer. And we'll tackle that later. I remember to put my boxes. That's good. I have my title. I think everything looks good. So your first lab, using a graph, if you are in AP, it will be a rebound height lab, and if you are in pre-AP, it'll be a velocity lab. So I hope this is a nice refresher. When you come into class, there is a graphing skill sheet handout that I will give to you, and you will all take that in your lab book. That way you can always refer back to it when you have to do a graph. And I hope this was clear, and I'll see you in class on Monday, and I will ask you if there's any questions. So have a good day.